Hi guys, welcome to the first lesson in second semester. We are starting with 7-2, multiplying powers with the same base. Now for chapter 7, we are going to be skipping around a little bit in the book. We're going to be doing parts of lessons, and then we'll do other parts at other times. So I'm going to try to reference which section in the textbook we are working from, but it may not be everything in that section. So today our objective is that I can multiply powers with the same base. And now we just need to talk about some vocabulary words. So the first vocab word is an exponent, and that is the small number that shows how many times the base is being multiplied. So I'm going to just write an example off to the side here. So the exponent is going to be this little number up at the top. Okay. The base is the number that is being multiplied by itself. All right. And a power is the base and the exponent together. So we call the whole thing a power. The base is the number that's going to be multiplied a bunch of times, and the exponent tells us how many times it's going to be listed. All right, our essential understanding is that you can use a property of exponents to multiply powers with the same base. You can then write them using one exponent. All right, now problem 0 is a little bit of an introduction, things that you guys didn't get last year since you didn't have 8th grade math. But we're going to go through them now. So we have exponential form, which is a number that has an exponent. It is a power. We have a base raised to an exponent, and it is 4 to the 5th power. So that means we are going to multiply 4 by itself 5 times. Now, in expanded form, we list out each and every one of those terms. So in this case, it'll be 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5 terms. There are 5 4s in our number. Now, standard form is where we actually do the math and find what it is. So using your calculators, you're going to be using the caret button, which is right there. So you type in 4 caret 5, 4 to the 5th power, and hit enter, and the number is 1024. All right. So now we're looking at the expanded form is what I'm being given. So I need to figure out what my exponent is. So my base is going to be 5. That's the number that's repeatedly multiplied. How many are there? There's 1, 2, 3, 4, 5, 6, 7, 8 5s there. So it's 5 to the 8th power, which when we type into the calculator, 5 to the 8th power is 390,625. Now, there are ways that you can go from standard form into an expanded or exponential form. And this could be actually 2 different answers, because 16 breaks up into 4 times 4. So we could have a 4 squared exponent, which is just 4 times 4. Or we could, because if you'll notice when I did my factor tree, I can divide those 4s up into 2s. So it would be 2 times 2 times 2 times 2, which would be 2 to the 4th power. So 2 to the 4th and 4 squared just happen to be 2 different powers, 2 different exponential forms that would lead us to the exact same standard form. All right, so problem number 1, multiplying powers. When multiplying powers with the same base, the exponents are being added. Okay, so our example is if we have x to the m times x to the n, that's going to equal x to the m plus n. All right, so we are going to be adding our 2 exponents. So we have 12 to the 5th times 12 to the 3rd we write it as 12 to the 5 plus 3, 12 to the 8th power. Okay. Letter B, we have x to the 4th and x squared. So this would be a good one for me to show, just kind of give another way of explaining why we are adding these together. So if we broke x to the 4th into its expanded form, it would be x times x times x times x. There would be 4 x's there. And we're multiplying that by x squared, which is 2 x's. How many x's do I have in total now? 4, 5, 6. X to the 6th power. Okay, so 4 plus 2 would be 6. Now, we need to make sure that they have the same base. So in this case, we have 0.6 and 0.6. So the base could be a decimal. So we have 0.6 to the 4th power, 0.6 to the 2nd power. Same base. We're going to add our two exponents. So 4 plus 2, we have 0.6 to the 6th power. Okay. Now we can also have negative exponents, and we're going to go into much more detail on negative exponents a little bit later. But right now, since we are just combining them, we're looking at what is the base. Our base is 8. Our exponents, we have negative 3 plus 6. Negative 3 plus 6 is 3. We can also have fractions as bases. So we have 1/3 to the 3rd power times 1/3 to the 7th power. So they have the same base, so we're going to add our two exponents. So we have 1/3. 7 plus 3 is 10. Okay. We can also have exponents that are fractions. We call these rational exponents. And we are going to be tackling and dealing with rational exponents a lot more in Chapter 10. We're not going to deal with them much here in Chapter 7. All right, so we have the same base. So we look at our exponents. We need to add them together. So 1/4 plus 5/4 is 6/4. But we all know that we should reduce our fractions to their lowest terms. So that's going to be y equals 3/2, or y to the 3/2 power. Okay? All right, moving on to the next page. I want you guys to try letters G, H, and I on your own, and then we will go over them. All right, letter G, we have a base of -4, so I'm going to start with that. Wrote my base down. My exponents, we have a 2 and a 5. We are adding them together. 5 plus 2 is 7. Next up, we have letter H. We have the base is the same, 1.2. And our exponents, we have a 5 and a -3. 5 plus -3 is 2. So that'll be 1.2 squared. Letter I, we have the same base. They're both x. We have a -1/3 and a +5/3. -1/3 plus 5/3 is going to be 4/3 as your exponent. Okay. Now moving on to problem 2, multiplying powers in algebraic expressions. The first thing we need to do here, we're going to start with the coefficients. Then powers. So we're going to start off by multiplying any coefficients that we have, because if you remember back to Chapter 1, the property rule, or the rules for multiplication, we can multiply in any order. We are still going to get the same answer. So we have 4 times x cubed times 6 times x to the 5th. Well, if we said 4 times 6 first, we can do that. And 4 times 6 is going to be 24. So we multiply our coefficients first. Then we tackle our exponents. So we have a base of x. We We have x to the third power and fifth power. 3 plus 5 is 8. So your final answer would be 28 or 24x to the eighth. All right, letter B, we've got 3 different terms here, but we still have one coefficient, another coefficient. 5 times 3 is 15. We have 1x plus 5x's plus 2x's. That's going to be x to the eighth power. So it's 15x to the eighth power. All right, letter C. We'll start with our coefficients. So we have a 2 times a 2. 2 times 2 is 4. We have rational exponents again. So it's 4 times c to the, we've got our 2 exponents. So we have 3/5 and 3/5. Add those together and we get 6/5. Okay? All right. Now I'm going to skip down to letter H because it looks a little bit different than all of the rest of them do. So I've got B's and C's, but they're in parentheses. But everything's being multiplied. 2 parentheses next to each other just means we're multiplying. So 4 terms being multiplied. Let's look at our items that have the same base. So I have B to the 2/3 there, B to the 4/9 there. Ooh, that gets tricky. Well, 2/3 we need and 4/9. If we want to add fractions together, they need to have the same denominator. So I need to convert 2/3 into ninths, and we're actually going to multiply both of that by 3. So this is actually B to the 6/9 and B to the 4/9. B to the 6 plus 4 is 10. So we have B to the 10/9. Make sure it looks like a B, not a 6. Maybe I'll just make it a capital B. All right. And we need to work with the C's. The C to the 2/5, C to the 9/10. Well, I got to convert that 2/5 into tenths. So that's going to be 4/10 because we're going to multiply by 2 over 2. So 4/10 plus 9/10. We're going to have C to the 13/10 power. So I'll rewrite that below. B to the 10/9, C to the 13/10. I just rewrote that because my B got sloppy. All right. I want you guys to go through and do D, E, F, and G on your own, and I will go over the answers for you. So letter D, we have n to the 1/3 and n to the 5/6. We need to convert that and get those fractions so they have like denominators so we can add. So we're going to multiply by 2 over 2, and we get n to the 2/6 power. So n, we have 2/6 plus 5/6, that is 7/6. Okay. Letter E, we have coefficients again, so we need to multiply those first. We have -3 times 2 is -6. I've got y to the 3rd, y to the -2nd, and y to the 1st. Usually that would just be written as y. So we have 3 plus -2 plus 1, and that's going to be y to the 2nd power. 3 minus 2 is 1, plus 1 is 2. -6y squared. Letter F. We have 3 different coefficients to multiply. So we have a 6, a -1, and a 5. 6 times -1 is -6, times 5 is -30. Now we need to look. We have a y, and a y. So we have 9, 2, and -4. 9 plus 2 is 11. Minus 4 is 7. So -30 y to the 7th power. Okay, letter G, we've got a coefficient out in front here. So we're going to start off with that one. We only have the one coefficient, so it just says 3. Our next term, we've got a j, so we've got j to the second and j to the third. So we have j to the 5th power. And our last term of k, we're going to have k to the 4th power because it's not being multiplied by anything. Okay? So that is all we are going to tackle out of chapter 7.2. We're only going to do problems 1 and 2 for now. We're going to come back to some of the other things a little bit later. We're going to pick up scientific notation at the end of this section. So make sure that you fill out your level of understanding. Rate yourself 1 through 4. I'm totally lost. to I could teach this lesson. And make sure you write a summary of what you learned in this lesson and what the rule for multiplying powers with the same base is. Have a great night, and we will see you in class.